Okay. Hi, pal. Tony Lockwood here in Cleveland at CAASE 18, co-hosted by Nathan's and, of course, Digital Engineering. I have a special guest with me, and I would like you please introduce yourself, introduce your company, and tell us what kind of products you make and why an engineer working with simulation wants to talk to you.
Great. So, my name is Patrick Greenberg. I am a French citizen, so sorry for my accent. I graduated from an engineering school, came to the US for a PhD in structural dynamics in California, loved California, stayed there for 8 years working in engineering world, simulation, finite element analysis and things like that. Moved back to France a couple years after and joined at that time a small startup called Dassault System. Maybe you know about it. We were a couple hundred people.
Yeah.
I think they're about 15,000 now, something like that. And I learned about CAASE, good CAD, and I was involved for marketing and sales and supporting customer on CAASE for about 5-6 years and sell CAASE to Boeing for the 777 paperless aircraft, for example. Mm-hmm. Then I had an idea. I wanted to start my own company, and my idea was I knew about CAD, I knew about simulation, and one issue was how to make those two areas work together. At the time, it was totally separated, and people were spending more time cleaning CAD to make meshing and to simulate than do their own engineering work. So I started my company by myself, only one person. Digital product simulation stands for how I'm going to use the numerical digital to make a better product. So I started this company and I developed it for the last 21 years. Now we are about 150 engineers worldwide. We're having office in Paris, in Toulouse, and Dearborn in the US, as well as Japan, where we deal with mostly automotive and aerospace industry. What do? We are providing enhanced solution to help people to collaborate between different physics, different type of simulation, design, and now even more go to manufacturing and to understand how to manufacture the part, especially now with the venue of the additive maturing process, where it's simulation, design, optimization, and manufacturing at the same time that you need to optimize. We are providing tools, expertise, consulting, and we have been doing a lot of research and development to find new solutions. And one where we are presenting here today at the CAASE event in Cleveland is a product called CAASE, that stands for Knowledge Acquisition and Reuse for Robust Engineering. And it's a collaborative tool that allows people to share knowledge. We do not share models. We leave the model in their authoring tools, but we will share knowledge, which is parameters, rules, relationships, things like that, that will are essential to collaboration, to allow people to do real collaborative work, collaborative design, collaborative simulation, and to reach the better product and faster.
Now, what kind of challenges are your customers coming to you saying, you got to help us, you got to help us?
Basically, like I said, CAASE integration. A lot of people, simulation is a work for mostly experts. Still today, I know we go for democratization, but still you have to be an expert. CAD, now the tool which are very powerful, you can do a CAD in a couple hours, change it, modify it. Then you send it to simulation. Simulation will take weeks to mesh, hours to run. maybe weeks again to understand what happens. And then you come back and the simulation is still running and the CAD has been changed already or modified 10 or 20 times. So you are doing
Just
simulation,
wasted all that time.
doing a simulation that is, for example, if you do a crash test for a crash simulation for a car, you have to do a complete body, you have to modify it. And so there is some problem. So by integrating the simulation within the CAD, you allow basically democratization. And basically what we do, we don't give to the designer a simpler product, but we give a designer, this is an example of what we do. We give the designer the real simulation product, but we embed it in the CAD environment. So it doesn't have to go out and in, and we guide him to do all the intelligence that needs to be done in the simulation. The software, we develop the software, we will customize the software to guide the user, which is the designer. And now we have done a lot of projects in the past, for example, putting topological optimization at the designer level. Right. If we consider that topological optimization is a very mathematical complex process, right. But if you put it at designer level, it is no more a simulation tool, but it's a design tool.
Right, and
the additive manufacturing
what's going on really underneath. But
doesn't matter. He has an optimization tool. Then today, with the coming of the additive manufacturing, you can manufacture any type of part, any shape, and everything. The optimization for the designer is a fantastic tool.
Right. That's cool stuff you're talking about there. So you must be really enjoying the absolute revolution that's going on in the hardware for the graphics and HPC and all of that.
For us, all the tools are needed to do our work, but we are not involved in that. I mean, we are not, but we're using them. Absolutely,
leveraging it. Yes,
yeah, exactly.
Yes, yeah.
We are more in understanding what will be. When we go talk to one of our OEM customer, for example, we just started a very nice project with Toyota in Japan. I was very proud because it's one of the most famous company in terms of quality, and they had some issue about the people doing the style of the car, okay, and those people were doing just drawings because it looks good, but after, when he goes to crash, when he goes to CFD, when he goes to acoustics and all that, it's not that good.
Right.
So they told us, can you provide a very simple tool for acoustics, CFD and crash to the guy which is doing style, so when he does his shape, it's already not 100%, but it's 99% good.
Right, yeah,
so
it's on its way.
It's on its way, so it doesn't make big mistakes. So that's type of thing we do for OEMs like Toyota, and I can give you other example, but that's the example I can do.
All right, well, very good. Well, we're running out of time here.
Sorry, I'm talking too much.
No, you're kidding it. This has been great. This has been interesting stuff, and I promised you I wouldn't take long. Your website is DPS -us.com.
This is for the US side.
For the US one.
And the French one is dps-fr.com.
Okay. You got that, folks? Don't worry if you didn't. You can write the DE editors, and we'll make sure that you get it. The company name, again, is Digital Product Simulation, DPS. And Patrick, thank you so much for your time and telling us a little about.
Thank you very much for inviting me.
And thanks, pal, for watching.